Okay, we're going to do some problems on linear systems with word problems. Okay, so the first problem we're going to look at has to do with money. So there are a total of 25 dimes and quarters. So there's a total of 25 dimes and quarters, two different types of coins. The value of the collection of coins is $3.85 or 385 cents. Okay, find the number of dimes and quarters. So you need to find how many quarters there are and dimes there are in this problem. Okay, so let's take a look at this. So what we do first is we make a let statement. Okay, so the let statement tells us what variables we're going to use and what units they are. Okay, so for this one we're going to say D equals the number of dimes. Okay, so there's no units, it's just a number of dimes. And Q equals the number of quarters. Okay, the first equation is D plus Q equals 25. That is a total number of coins. So remember, it says in the question there are 25 dimes and quarters. Okay, so 25 in total dimes and quarters. The next part is there's $3.85. So $3.85 worth of money, which is 385 cents. Okay, so this is the equation we get from that, where D is the number of dimes. 10 times D is going to be the amount of money you get from the dimes. So if you had 5 dimes, you'd have 10 times 5, which is 50 cents from the dimes. Okay, and 25 times the number of quarters tells you how much money you get from the number of quarters, and these two should add up to 385 cents. Okay, so those are the two equations. Now that you've got the equations, you can just solve. So from the first one, I'm going to rearrange it, and I'm going to get 1 star, which is D equals 25 minus Q. I'm going to take that and sub it into equation 2. When you sub that in, you're able to now solve for Q because you've eliminated the D. Okay? Rearrange the equation a little bit. Isolate for Q, and you get Q equal to 9. Once you've got Q equal to 9, take that and sub it back into 1 star. You have a definition for D here. So sub it into 1 star to solve for D. Okay, and you get 16. So there are 16 dimes and 9 quarters. And the next question we're going to look at is one just to do with straight numbers. Okay, so this one here, two numbers sum or add to 45, and then twice the first number subtract 3 times the second number is negative 35. Find the two numbers. Okay, so this one's fairly straightforward. There's two numbers add to 45. So we're going to do this let statement here, okay, which is let x and y be the two numbers. Okay, you know they add to 45, which the question said, and then it said twice the first minus 3 times the second is negative 35. So now you have two equations with two unknowns, and you can use substitution or elimination to solve this. I'm going to use substitution, where I'm rearranging equation 1, and I'm solving for x, sub into 2, and continue on. To sub it in, you have to expand to get rid of the brackets, collect like terms, isolate the y, and you get y equal to 25. Okay? So the first number is going to be 25. How do you get the second number? Well, you sub the first one, the x, or the y, into the equation for x, and you're able to solve for x equal to 20. Okay? So the two numbers are 20 and 25. All right, next question, let's take a look here, is question 3. All right, so question 3. Linda sells chocolates for $2 per kilogram and jelly beans for $4 per kilogram. To make a mixture selling for $2.40 per kilogram and a total of 100 kilograms, what is the mass of each needed? Okay, so out of the 100 kilograms, how much of that mass should be chocolates and how much of that mass should be jelly beans, is what they're asking. Okay, so what we want to do now is make some let statements for this. Okay, so let's do this. So in this question you've got, I'm going to let x equal the mass of chocolates in kilograms. You must include the units. Okay, and y equals the mass of jelly beans in kilograms, including the units. Okay. So at this point, we've got that the total mass must add up to 100 kilograms. Okay, so x plus y is 100. That's the total mass. And then the next equation, we're going to look at how much it's going to cost. Okay, so if 1 kilogram of chocolates costs $2, then x kilograms of chocolates is going to cost 2x. Okay, so it was 10 kilograms of chocolates, it would cost $20 because it's $2 per kilogram. And same thing for jelly beans, it's going to be 4y. If the cost per kilogram for the whole thing is $2.40, then 100 times $2.40 will give us how much it costs for the whole 100 kilograms. So 2.4 times 100 gives you the cost for the 100 kilograms. And this is how it's broken down. Okay? And then I would write that as the second equation. So now that we've got the two equations, same thing. From 1, it's a nice easy equation. I'm going to solve for y. Call that 1 star. And then I'm going to sub that into 2. Same idea. Sub it all into 2. And if you need to go slower and try this, you should pause the video and try it yourself. And then come back and see if you got the right answer. So isolating x, get x equal to 80. Sub that into 1 star. And you get y equal to 20. Okay, so you'd need 80 kilograms of chocolates and 20 kilograms of jelly beans. All right, next question is question 4 here. Okay, question 4, a little bit more complicated. So Brian's average mark on 3 math tests was 78%. Say. The mark on the first test was 86. So you got 3 tests, you know what the first one is. His average for the first 2 tests was 3 more than the mark on the third test. What marks did Brian get on the second and third test? So we know the first test, we don't know the second and third, so our let statement is going to be for the second and the third test. Okay, let's take a look at this. So let x and y be the marks on the second test and y in the third test. Okay, you know that the average of the 3 tests is 78. So how do you calculate average? You add them all up and divide by the total number. So add them all up and divide by 3. Okay, so that's what you get for the first equation with the x and y. Add all these up, divide by 3, gives you the average of 78. Okay, and you rearrange that. Multiply by 3, bring the 86 over, and you get x plus y equals 148. I'm going to call that equation 1. The next statement says that the average of the first, his average for the first 2 tests, so that's the 86 and the x, was 3 more than the mark on the third test. Okay, so the average of the first 2 tests, 86 plus x, divided by 2, that's the average. That is 3 more than the mark on the third test, so this. Okay, again, we're going to simplify that a little bit, bring the 2 up, multiply it out, simplify so that we get x equals to 2y minus 80. Now we can sub that into 1. Okay, by subbing into 1, we simplify, isolate y, and you get y equal to 76. Okay, sub that into 2 to get x, and you get 72. So Brian got 72 on the second test and 76 on the third test.